So like I said, I think you should have fun while you're learning science. So we've got these holiday science lessons. This is based on Halloween. There's really two parts to this. And if I were doing this, this would take probably 2 days in a real classroom. Okay? And I think you could do this middle elementary up through high school. So part one, the question is, which pumpkin has the most seeds? Take a look at your pumpkin at your table, okay? And then look around at the other pumpkins.
Ours is a little small.
Yeah. Yours is small. Okay. So if you had to guess, you know, which pumpkin has the most seeds, you know? Yeah, you'll be partners with Nate. Okay, so that's the first question. Everybody's pointing over to the biggest pumpkin must have the most seeds. The second question is, how is the earth like a pumpkin? And there's like I said, there's 2 lessons here, and we're combining them. So you need to keep your mind open. All right? Now let's go back to the first question. Which pumpkin has the most seeds? How might you make that kind of a prediction? Ray, I saw you and Ian were both pointing over that this is the biggest pumpkin over here. Yeah. Yeah. Who says this one has the most seeds? Ian and Ray. Jim, Adi. Why? Ray, why do you think this has the most seeds?
It's bigger.
It's bigger, and how would we measure bigness on this?
The size.
Like size 5?
Yeah. I'll give that about 5.5.
5.5. Well, I think maybe you might want to measure it, like the diameter. What else? About the number of seeds, Michaela?
Well, you could also think about it as the space where the seeds are.
Yeah, it's true. If it's more massive, maybe there's, if we have the pumpkin, we know its mass, consider measuring size as the diameter. But it's a really big pumpkin, just has a really small area on the inside. It could be, we refer to this in the United States as the meat. It's the meat of the pumpkin. It's the part you would eat. Or it may, you know, and you might have a smaller pumpkin, okay, who has a larger size on the inside. So that might have something to do with it. Okay? That's something else we might know. Anything else? Anything else about the pumpkin that might tell you about the number of seeds?
Are we just like guessing? Like,
what if you happen to know where the pumpkin came from? Like the seeds that, or the plants that came, yeah.
Where it came from.
Yeah. Its heritage.
Its lineage.
It came from
this pumpkin tree.
Something like maybe seed stock.
Yeah.
Like maybe certain types of pumpkins have more seeds than others, right? Yeah, so that could be like seed stock. So there could be some kind of genetic thing going on here. It also might be where it's from. Maybe like geographically, maybe pumpkins in a warm climate, you know, grow more seeds than pumpkins in a cold climate. Or maybe the reverse. Right. So it could be a geographic kind of idea. Now, is there any other physical characteristic of the pumpkin which might tell us something about seeds? What are those things? You're absolutely right, Ray. How would you call those things?
Slices.
Kind of like slices, lines that go from the top to the bottom.
Oh, like what's the word for freaking Earth thing? Longitudinal? Or is it
yeah,
longitude.
Longitude. Long, longitude, long, latitude, latitude. So maybe, do you know what, does anybody have a common name for these things? Does anybody ever call them anything before besides longitude lines on a pumpkin?
Or slices.
Slices.
Wrinkles.
Wrinkles. Maybe ribs. Has anybody ever heard of that? Ribs? No? Well, anyway, these lines.
What's that, tree? Pumpkin? Would it be like tree rings or something, or a different sort of rings?
Yeah, something. Maybe we could call them anything we want. I think.
Oh, okay.
But we do know what we're talking about, though, right? It's the lines that start at the stem and then go down to the bottom, and you might be able to count them. Now, how could we use inquiry to determine if any of these characteristics help us predict the number of seeds? That's a very high-level science question. Jim, what should we do? What are we going to do here in this to solve this?
Well, I guess each group could take one of the different options up there and measure it in whatever way, and then open up pumpkin and find out how many seeds there are.
Count the seeds, yeah, we could do that. So we'll use this data table here. You don't have to do, you can collect the data at your table. But I think what we'll do is we'll have each team, okay, measure the mass of their pumpkin. How are you going to measure mass?
Scales.
Yeah, we're going to use the scale over here. This scale measures up to 5,000 grams, but you know, that thing's more than 5,000 grams. So let's just use the scale and get an approximate mass, but we're really going to be measuring it as weight. Okay, let's also measure the diameter, okay? And that would be, the diameter would be to try and find the middle spot and find out the distance around. Is that diameter, Michaela?
Yeah, but I have a question. If we're just measuring the diameter there, does it matter that like they're not all the same shape? So some of them are tall and skinny, and some are fat and short.
Yeah, that's right. So maybe do you want to measure the diameter around the middle and over the top too?
Yes.
Okay. So we'll do diameter around. That's a good thing.
It's
Around.
actually circumference.
Oh, that's right. It is circumference. It's not diameter. Thank you, Jim. That's why I was circumference. Around and top to bottom. Okay? And then finally, all right, I want you to count the number of these lines, or ribs, or longitude lines on a pumpkin. Okay? So whatever we call those lines, let's call them the longitude lines. And then in the last column, we'll put the number of seeds. Okay? All right, let's cut the tape there for a second. So how the pumpkin is like the earth. So I want you to put a dot on your piece of paper. One dot with your pencil. Okay? Now I want you to tell me where the dot is.
At the center.
Oh, okay, we have one in the center. Adi, where is your dot?
Can't see it.
In the center, two in the center. Yeah? Center. Oh, everybody's putting it in the center. Did anybody not put it in the center? Michaela, did you?
Sort of.
No.
No, you put it in the center
No, I
too?
did not put it. What? No, I put it on, no.
Where is it?
I put mine
We're good, we're good.
it was like on the left side on your drawing, because I always have my paper this way.
Left side.
Like, I put it on the top of my paper, but I have my paper the other way.
Oh, so it's like
it's on your, yeah.
it's like here.
Well, no, like in the center of the top though.
Center of the top. The center of the top.
Close enough.
Oh, the center of the top, here.
Yeah.
Okay. Good. Just you have to know which way it's oriented.
That's true.
That's a good one. I like that. Okay. Now, Nate, how about yours? Where's yours? You have to use words. Tell me where it is.
It's in the same place as Michaela's.
Oh, that's easy. Now, how about?
Oh, you forgot ours.
Oh, where's yours? Right.
Alright, so
Im, where is it? Im, where's yours?
Let's go from the center. You go diagonal to your right, up. Go forth. Yeah, right there. Oh, back a little bit. Oh, there you go. There you go. Yeah.
Now what if I give you a ruler? Now, tell me where it is.
Yeah. So, was that 13?
No.
Yeah. 8.8. Okay.
How far?
Okay, Sue, where is yours? Where?
4.
Anybody ready?
Yeah.
Nate?
5 centimeters from the left, 10 centimeters from the bottom.
5 centimeters from the left and
Yeah.
10 centimeters from the bottom.
10 centimeters from the bottom. So it's here.
Up there.
It's in almost in the middle, more towards the left. Yes.
All right, so I'm good with that. So we have directions. All right, now Sue, yours?
3 centimeters on the top.
3,
Yeah, but we're doing it from above picture. So
Right.
Yes.
3,
3
3
down.
centimeters.
3 down.
And 11.
11.
11 from the left.
from the left. So there, okay,
So on his it would be like 3.
right here.
No, where, what's it, if you're using the same one that Nate put his on?
The bottom, yes.
Like it'd be 3 over instead of 5 over,
Okay,
and 10, 11 up instead of.
3 and 11, something like that. Okay, great. And Art, how about yours? Where's yours?
13 centimeters from the top.
13
Oh,
down,
no, I mean from the left side
13,
and in the middle.
right.
And,
And how-
we didn't do that.
only one set of directions leaves me with something along this
10.
line.
10 centimeters.
10 centimeters down, okay, great, so it's somewhere in there. All right, I think you get the point, all right? When you've got a two-dimensional surface with boundaries, okay, you can give directions about where it is using words, but you can also do it using numbers as well. Here's a different kind of a problem, okay? Okay. Find a point on this round sphere. Find a point, put the pin in it.
No, I always get into it.
Right in that point, that exact point. Is that one? Yeah. All right. Okay.
There we go.
Where is it?
Wow.
It's just
Tell me where it
just
is.
trying to determine measurements.
Okay. Come on, tell me where it is.
It's a point on the sphere.
Anyway.
Yeah, where?
The North
It's
Pole.
on the sphere.
Oh, the North Pole. We got one on the North Pole. Great.
Ours is on the equator.
The east side of the equator or the west side of the equator?
What the pole?
East or west side?
What is
It's on the side, right there. I can see it from here. Michaela, where's yours?
Ours is holding up the world.
It's holding up to the top. Yeah, where's yours? Where's your point?
38 degrees north,
Right about there, from what I can
52
tell.
west.
Well, it look like this. The top?
It's at the top. Another one at the top. Yes, Matt?
I was the first one.
Yeah, okay, great. All right. So you can see when you move to a three-dimensional object, not two-dimensional, flat, but three, it becomes a little more difficult to describe where the point is. And in fact, you use this idea of the North Pole, okay? Which means we know about the North Pole because evidently, according to the book, it's the axis around which the Earth spins, okay? So if we want to describe where Thailand is, okay, we can say it's right here. It's a little bit north of the equator, right?
Somewhere nice and
Top
warm.
half. It's over by India and Australia and some other place. Yeah, some other place. What if you were on the moon? How would you describe where you are? How would you describe if you were on the moon? Does the moon have a north and south pole and an equator? Does the moon spin?
Yes.
So maybe it does have a north pole. And if you have a north pole and a south pole, you can do those longitude lines, right? The longitude lines go like this, and the latitude lines go like this, okay? So we can take a sphere and we can divide it up with longitude, latitude. Okay. Here is the challenge, okay? I want you to design a Halloween face for your pumpkin, okay? A Halloween pumpkin face, okay? And I want you to write directions on how to make that face.
Can we do it on our pumpkin?
Yes, you can use those. We'll use these vis-a-vis markers because they are washable, so we can wash off. You can use a method, okay, to describe where you want the face. Okay? Do you understand what I'm saying here? With Art, do you understand? Now, the idea is for you, let's say on your piece of paper, okay, let's say you take your piece of paper like this. And on one side, draw the face. And on the other side, write the directions. When you're finished writing the directions, I am going to take your directions and give it to another team. So I'll give it to Yao and Nate. They have to follow your directions and then compare your picture to their face. They will carve the face.
So you want to rip them out?
You could, yeah, we're going to have to rip it apart eventually. That's right. And don't show the face to the other teams, so they won't know. They won't know. So we have now about like a half an hour, 40 minutes. I want you to do two things. I want you to measure the mass, the circumference, the longitude lines, and then I want you to count the seeds when you're finished. And when you're finished with counting the seeds, put them in the plastic bag and I'll take them home and cook them and bring them back to class to eat. And we'll eat the seeds, okay? And at the same time, I want you to be designing a pumpkin face and writing directions that we're going to give to another group. And they are going to create that face, and we'll see if it matches your face. Do you think you can do this?
Try.
Also. All right, let's go. Okay, I think you understand. I'll take the balls back with the pieces.
But I never read
Oh, man. So now it should, see, you should be able to try it out something. Maybe
I don't know. Swear?
Maybe.
Alright.
Are you gonna be like using these for like real jacklines?
Mm-hmm.
Because this one might be dead at the top.
Yep, well, we'll do the best we can with what we've got. But I will use them. I might even cook them.
I don't know.
Here, I
Here.
stab it now.
Let's use that one.
to be 2 units.
There we go.
We got it. Okay.
6.
It's about 4, 3.5, 4, about 4.
No, we just right direction. Then somebody else will cut. We'll try to make this.
Okay, right there. Yeah, we'll take it off the side. I'll put one thick one down for 100.
Use the round side, so we'll start on the smoother side.
We need to pull off more of the stem. It's stuck now in the pumpkin. And we don't.
Oh, okay.
Smooth,
So now we're saying this is done.
round. Right, that makes sense. Okay.
Technically, no, because we want to
I think that's it for seeds.
Yeah, I mean, for seeds.
Oh, there's one more. Okay. Next step is we'll just start
So now we need to try to explain how to make this.
Okay, let's just start.
You have to measure.
Let's just measure. Well, because we have to give them direct instructions on how to do it. So maybe start from. Just rip this. So like.
So we got that now, we got there. This is the Montana State's Culinary School, School of Cooking.
From the top corner.
That's good. I think we got this. Oh, okay.
Side, down, here, drop.
Oh, you want to cut it up?
Yeah!
Okay. Got most of that. Oh. Five, 6. Okay, I get that now.
That's better.
Okay.
Oh.
Draw a 4-centimeter line down along 2nd and 4th longitudinal line. So 2, 3, 4. So okay. So now 4 centimeters down. So.
Pumpkins don't have noses.
There. Okay.
So you're supposed to count to the side?
Okay. That's 2 centimeters from here.
Right there. Now.
Make a rectangle.
It's so
Okay, so.
Make 4 dots 3 centimeters below equator, halfway between lines 2, 3, 4, 5, and 6. Take 2, 3, 4,
It's okay, I'll figure it
5,
out.
6.
You can keep counting if you want.
So, okay, make 4 dots 3 centimeters below.
Maybe I'm just sticking
That's good.
It'll be straight when we cut it.
Yes.
Okay, so check that.
pumpkin
Check that.
carving issues.
From the top corner of the rectangle, cut up 4 centimeters diagonally towards the center.
Have fun.
Cut up 4 centimeters diagonally
I don't understand how we have
towards the center.
Yeah.
We don't know how to cut this one out. I don't know how.
We should write this down before.
Okay. Oh, make 4 dots.
the two ones that
Okay. Yes, that looks good.
My teeth, yeah.
Okay.
I didn't know if you meant like, I see, I think meant like long
Yes.
openings, so I'm like.
Yes,
so
I think.
yeah,
Oh, that way,
So I wasn't sure
oh.
which way.
Yeah,
So-
I should have made a little, another figure.
I knew it was wrong, because I'm like, why would you have like a line or a little
Yeah.
square, but.
Oh, well, it's,
Can I cheat and change it now?
yeah, you
No, you can't
After
cheat.
consultation.
No cheating.
Apparently, no, I can't change it.
can. Consultation.
You don't condone cheating in this matter?
Fine, not cheating, correcting my
Now,
mistake.
who's
Whose picture is
Who
that?
forgot?
Hang on a minute.
Let's see the picture up there.
Oh my god! Oh, you did it really high.
Good artist.
All right.
I think it's
A, B, C, or D?
Yeah, it's like he's got a huge chin or something.
That's so weird.
Okay, who's next?
Oh, no. Oh!
We tried.
Here,